Good morning, mathematicians. We are looking at our final column of week 2. We're looking at Thursday. We are to solve this and write our answer as a fraction. They've even given us this hint that the denominator will be 100. So if I have 5/10 and I want to add 49 hundredths to it, that's what I'm starting with considering. Well, first of all, I know that 5/10 can be converted to an equivalent fraction with a denominator of 100, right? Now, how I could do that would be to multiply both the denominator and the numerator by 100. So 5 times 10 is 50. And then, of course, 10 times 10 is 100. So in this way, I've created an equivalent fraction. And now I can add 47 hundredths to that. Now that my denominators are the same, I can simply carry down my 100 to be my new denominator, which of course is the same, and I can apply the operation to the numerators. 50 plus 47 is 97. So my answer is 97 over 100. That is the answer to our very first question. Our next question is asking us to consider fractions and to compare them within this context. Buzz Aldrin says that 3/4 moon is smaller than a 3/5 moon. Is he correct? Notice, boys and girls, I went ahead and drew a model here that is a whole divided into 4 pieces, right? The denominator, the bottom of our fraction, tells us how many parts the whole is broken into. The numerator, in this case 3, tells us how many of those parts we have. This shows 3/4. Now, over here, I have divided my whole into 5 parts because the denominator tells us how many parts the whole is broken into, and the numerator tells us how many of those parts we have. In this case, we still have 3. I can clearly see that this is greater than this. Now, the reason for that has everything to do with the denominator, right? If I have a denominator of 4 and another denominator of 5, I know that each particular piece of this whole is going to be larger because a quarter is bigger than a fifth. And that is really what this goes back to. So we need to say, is he correct? Well, no, he's not correct. That is the first thing I'm going to say. And then, how do you know? I'm going to say that a quarter is bigger than a fifth. And that's really what this question is getting to, is having to do with the numerator is the same, the denominator is different. Well, each piece of the pie is going to be larger over here than it is over here. Now, let's come down to solving some more fraction computation. Here, we're going to be thinking about 4/6 minus 1/12. Well, the first thing that I have to do is I have to convert I have to convert. Oh, I wrote this down incorrectly. This is actually 1/12 here, right? So I'm going to switch this up just a little bit, how I have this written down. And boys and girls, this is what mathematicians do. Sometimes we have to change our approach. If we notice that we have something incorrect, we will do that. We all do that, mathematicians. Making a mistake is not a sign of anything different than just being human, right? So we have 4/6, and we're going to subtract 1/12. So actually, this is the fraction that I'm going to be converting. I need to change this into an equivalent fraction that has a denominator of 12. So what do I multiply 6 by to get to 12? 6 times what equals 12? Well, 6 times 2. Well, whatever I multiply my denominator by, I'm going to multiply my numerator by the same thing. 4 times 2 equals 8. So I know that 4/6 is the same thing as 8/12. Well, now I could just carry over this because I'm going to subtract these. 8 minus 1 is 7, and my denominator stays the same at 12 because I'm thinking about those equivalent fractions and then applying my operation on the numerators. So my answer here to this question is going to be 7/12. Now we're going to do that again with two other problems. Let me get a nice piece of blank paper and let's go ahead and solve this in a similar way. So here I have 7/8 and I'm going to be subtracting 19/24, right? Now, right now, my denominator is not the same. So my first job is to create equivalent fractions here, an equivalent fraction here, so that I have a denominator of 24. This fraction has set the denominator, right? I need to make this one match. So I'm going to ask myself, 8 times what equals 24? Well, that is going to be 8 times 3. 8 times 3 equals 24. 7 times 3 equals 21. So I know that 7/8 is the same thing as 21/24. But now I am looking at common denominators. So now, boys and girls, I can carry down my denominator, 24, 24, 24, and let's apply the operation to the numerators. 21 minus 19 is 2. So my answer here will be 2/24. Or since these are both even, I could divide them by 2, right? 2 divided by 2 is 1. 24 divided by 2 is 12. So really, boys and girls, either of those we would accept as a correct answer because they sit on the same place of the number line. So I'm going to go ahead and write 2/24 or 1/12. Okay, let's do our last problem for this particular skill where we're thinking about subtracting fractions. Here we have 13/15, and we're going to subtract 2/3. Now, I need my denominators to be the same. So I'm going to create an equivalent fraction with a denominator of 15. So I'm going to ask myself, 3 times what equals 15? 3 times 5. I'm going to do the same thing to my numerator. 2 times 5 equals 10. So now I have an equivalent fraction that matches the denominator of my other fraction, so I can now subtract. My denominator stays the same. It is a 15, and I have 13 minus 10 equals 3. So my answer to this problem is 3/15. I'm going to come back and write my 3/15 here. This was a great opportunity to review subtracting fractions that don't have a similar denominator, the same denominator. And the first thing that we have to do is get that common denominator. All right, in our next question, boys and girls, we are writing a fraction for each of the below. 37/100 is going to be written as 37 over 100. This is the same as 37/100, right? Now here I have 8/10 plus 14/100. Well, remember, boys and girls, that 8/10 is the same thing as 80/100, right? In 8/10 we have 80/100. So if I have 80/100 plus 14/100, if I combine those, I have my answer of 94/100. Or 94 over 100. This is really the answer that we're going for because remember, we were asked to put these into fraction form. So what I've circled is the answer that we should have 94/100. But remember, that's the same thing as this idea of combining the 80/100, 14/100, 94/100, which is the same as 94 over 100. All right, our very last question for today is Neil Armstrong spacesuit weighed 80 kilograms, 700 grams in total. Now his helmet weighed 13 kilograms, 600 grams. How much did the rest of his suit weigh? So remember, boys and girls, this is the whole suit. And one part of that suit was the helmet, right? We want to know what the rest of the suit weighed. So what we're going to do here is subtract. Well, if I have 700 grams minus 600 grams, I get a difference of 100 grams. If I have 80 kilograms minus 13 kilograms, I get a difference of 67 kilograms. So in this way, boys and girls, we know that the rest of the suit weighed 67 kilograms, 100 grams. Okay, and that finishes out our Thursday